Hi, Morten. Welcome to Comunidad Valiant.
Hi, Santiago. It's fantastic to be here. Thank you so much for having me.
Okay. Morten, tell us who Wind Power Lab is.
Wind Power Lab was a company started back in 2016. We were originally four founders who all worked within renewables at Dong Energy. That was a major Danish offshore utility company. And the problems that we were facing on blades on offshore, we kind of recognized that that would be an issue globally. So we decided that the technology and know-how that we had built up over the years working in offshore operation, that we could use like that and support the entire industry. So we founded the Wind Power Lab on the basis of that, with a focus to support owners and operators. Over the years, we also expanded into support insurance companies, but the basis is the same. It is to how do you say it's to puncture some of the myths and making the what is often the black box around blade knowledge being more accessible to the broader community.
Okay, yeah. Well, we first were in touch with your team with one of our wind parks. We were impressed by the knowledge, and then we obviously had the chance of visiting you in Denmark back last year to really know about what you were doing in respect of blades and really understanding, right, all the complex nature of this asset. So nowadays, I mean, speaking of blades and the challenges that you have seen, what is the normal day-to-day of the Wind Power Lab team?
So today, some of our key focus areas is to support owners in factory visits. It's still sort of a novelty. Some owners do it, have been doing it for years. A lot of that are new, emerging into the industry. It's still a new thing for them, but we are supporting new owners with going to factory, trying to determine what is the baseline quality of the blades that are coming out of various factories around the world. So that's one area where we're currently quite engaging.
Is that prior to them selecting the OEM, or is that once they have already decided on a
It's
supplier?
it's when it's already been decided. In principle, we could help out owners with employers' requirements, but typically when we're engaging is when the OEM has actually been selected, and then it is from factory to grave. Really, we're very engaging in the first phase when the turbine is being constructed, in the warranty to determine what is the condition of the blade really when we're going out of warranty, and is it up to spec with what is the expected wear and tear. And then, of course, over the duration of the lifetime, because I mean, we have to accept blades; they are not perfect. So there is some requirements for repairs, and there are some requirements for inspections. So we're helping out owners quite a lot with this recurring maintenance that is required.
Okay, and getting into what you have seen in blades. You want to tell us what are the most common type of problems that you come across? Obviously, you're involved, apart from this early stage involvement, a lot of what you do is visiting sites where something has gone wrong, right? What
Yes.
are the main challenges that you see operational blades having nowadays?
Well, you could say it's split into three areas. So one is, of course, lightning. It's something that's very well known. Most operators and owners and insurers, they have encountered it in one way or another, where the blade is designed with some LPS system that is certified to LPL1 in accordance with the IC standard, but it does happen that lightning strikes outside of the receptors, which is something that does happen because lightning is not always predictable. If you line out your receptors, it's not always that your receptors will be the most interesting point for the lightning to attract you, and that will then mean it will hit the shell, and then further into the cabling, causing a structural damage. It can be a numerous array of factors to affect this: moisture on the blades, environmental conditions, topography, and the wind farm is located in, airflow distortion. All of that can influence the interaction between the LPS system and the lightning cloud. So that is still a major thing that we see. The second thing is operational conditions. So wind farms, as I said before, depending on topography, do experience a lot of different load conditions and wind conditions, and that will affect how how fatigue develops. Because if you don't see, uniform wind direction directed at the wind turbine at a precise, straight at the turbine all the time, that means you get more shear, you get more torsion, you get upwinds. That does affect the load capacity, because then you start to interact with areas where the blade is not as heavily designed, and then you can get some increased fatigue load, especially with newer blades that are a bit more, how do you say, optimized design. So there's not the same robustness as we saw with earlier design from the 2 megawatt and downward. They were much more conservatively designed because of the knowledge of the industry at the time. So the blades today are getting more sensitive to abnormal loading than what we saw in the past. So that's a major thing that we see. And then lastly, but not least important, is manufacturing quality. The blades are not, as we haven't. It has not been sold how to produce pristine blades. So we do still see air inclusions in the laminate. We still see wrinkles in the laminate. We still see ply drops. We see imperfect shear web shapes, and we also see that the consolidation of the laminate are not always what was intended, and the adhesion application. So this gives a myriad of different manufacturing defects that unfortunately do go into blades that are in operation. And that means that you then get early life structural damages. Luckily, a lot of them do get captured before we see a complete blade collapse. But as you know, it does happen, and that provides a very unfortunate situation.
Okay. Yeah. Well, you were talking about the evolution of blades. Obviously, we are seeing at the moment this incredible challenge of adapting these huge turbines, right? We were looking this week at the Mingyang. I think it's a 20 mega watt turbine with a 260 meter diameter. It's just amazing. I mean, has this size of a blade affected, or are you anticipating it affects the construction of the blade, how a blade is manufactured, or are you seeing the similar systems that you saw in similar blades?
So you could say the blade design overall is more or less the same as it was 20 years ago. The principle of the design is the same. You still have a shear web, you have a load-carrying structural beam, and you have shells to capture the wind and create the airfoil. So that is still the same. Nothing has changed on that part. Where we've seen a lot of optimization is actually in the shell region, where you have thin laminates, but maybe 10, 15 years ago, a thin laminate might consist of 5 to 10 layers in the shell. Today, that has been shaved down to the absolute minimum. So you're down to maybe 2 to 5 layers, or even less. So they're really to increase the length. They're consistently optimizing the way the laminate layup is being created, because that does shave off a lot of weight that then enables you to increase the length. So by reducing the weight, you can then the technique is to reduce the weight. And of course, there's also been a shift in the materials that are being used. Historically, it was mainly Vestas that used carbon fiber reinforcements in their V90s. They were some of the first to implement it, but it's become more of a, more or less a standard for most blade manufacturers, especially for the long ones, because it's the only way you can create a structural beam that is strong enough to sustain this long blade. but without creating a tremendous weight that would then make it impossible to create to have a turbine that can actually sustain that load. Because that's the second problem, is that whatever the weight, whatever the load of your blade is, then your turbine need to handle that kind of load. So the the race to bigger turbines is always in the weight of the blade. That's how they do it.
And has that changed the materials they use? I mean, how can they get a lighter percentage per square meter of blade?
It's in carbon reinforcement of the beam, and then thinner shell laminates.
So you're seeing more carbon being used.
Yes.
Does that have any effect on the lightning exposure, right? Because I would presume carbon could be much more attracted to lightning than before, or is that not being an issue?
Well, lightning is a conductive material, as you say, so it does create its own magnetic field, and the LPS system need to be able to handle that. Otherwise, you would just even with an increased blade, you would just see a lot more failures due to lightning damage. And lightning does attract to carbon, so there is a lot of so that does put a lot of pressure on the LPS system. So that is the main focus of the design, of course, is to continue optimizing the LPS to handle that, and we see some varying effects on how successful that is. But the tricky thing is that you have your LPS system that create when a lightning cloud is near your turbine, that then generates an electrical field or a corona, and the blade or turbine will do the same. And the more components that are then that are also conductive, that will then start to influence the LPS system's magnetic fields. And the more distortion that you have, then the higher the probability that you actually get a damage from a lightning strike. So it is an issue. We haven't seen everything yet. So we haven't seen the Ming Yang in operation for that long. So we don't know how good or bad it is. But I would say carbon is here to stay. Unless the OEMs decide to reduce the size of the turbines, they need to stick with carbon, because they can't go back to glass fiber with a 100+ meter blade. It's unlikely that they would be able to achieve that. So it's something we have to, if we want to build bigger turbines, it's something we have to live with, and then find good engineering solutions to handle the lighting issue.
So Morten, we're seeing obviously the with offshore wind still being a minor part of the overall installed capacity of wind, but getting bigger. Are you seeing different challenges for blades that are installed offshore versus the onshore installations?
So onshore, one of the challenges is that you have a lot more availability because you have more consistent winds. So the turbines are operating at a much higher rate compared to an onshore turbine. And an offshore turbine having 80, 90, close to 100% capacity is not that uncommon, because especially in the Danish west coast, the wind is just consistently blowing from the west. So you can have a month where you just have 100% production rate for a turbine. It just doesn't stop. And of course, that means that the blades are seeing more fatigue compared to an onshore. But even with that, they are still designed for a 25-year, 20-year lifetime. So in principle, that should not be a problem as such. And in principle, being offshore should actually be a better condition for a blade, because you have more uniform winds. So with that, and then also there tend to be a higher focus on offshore, on blade quality for offshore blades, because of the the problems with the operation and maintenance. It's very, very costly. So OEMs have an incentive to produce higher quality blades for offshore. So those two combined means that we do see actually less problems with blades offshore compared to offshore.
Morten, if I understood correctly, because of the cost it means, right, to getting a team to visit an offshore turbine, presumably also the cost of bringing a blade down are so much bigger than onshore. A much more focused approach is used into maintaining an offshore wind park than an onshore one.
Both maintaining, but also the initial quality seems to be a lot better for offshore compared to onshore. So there's a lot of positive factors for offshore operation in blades in particular that do seem to benefit the industry in that regard. Not that all onshore blades are bad, of course. There is a lot of good examples as well. But in terms of ratio, we do see more damages and more requirements for blade replacement on offshore with newer projects compared to offshore.
Okay, so have you had a chance to visit these offshore winds? I mean, have you been able to? It must be pretty amazing. I mean, it's also been the place for the larger turbines and the challenges of installing both the traditional structure as well as the floating ones that are pretty new. Must be pretty unique.
Well, I was fortunate enough to work in offshore operation for 3 years. About 10 years ago, I worked for Dong Energy, and then I had the responsibility for operation and maintenance on the blades for their portfolio. So that consisted of about 600 turbines at a time. So I had a lot of turbines and a lot of blades that I needed to do regular inspection and repairs of. I didn't have to do everything, but that meant that I had to go offshore to do regular checks of the condition of the blades. So I was involved in that, and I'm fortunate enough that I live very close to the National Center for Offshore Turbine Testing called Østerild. So whenever a new turbine is getting erected from a Western manufacturer, then it typically gets installed at Østerild. So an hour from my house, I can go out and then I can see these massive turbines operating on land and then see them up close how actually works. And if you're ever in nearby or anyone listening to this and you're in Denmark, I would recommend to go see that. It's public land, so you can go and then walk underneath a Vestas 17 megawatt turbine. It's fantastic.
Yeah, well, we'll do. Morten, and we were speaking about Mingyang's 20 megawatt turbine, and obviously it takes us to the question of how the OEM market has changed. We were looking at the 2024 rankings, and it's been incredible to see how Chinese OEM have taken this market, now occupying the first 4 positions of the top 5. Something that, I mean, we were hearing probably a year ago that this was going to happen. Probably no one expected this to happen so fast. How is this change affecting the market? Obviously, talking about how you see the relationships between owners and OEMs, has this impacted, or do you anticipate it will impact the way in which companies buying these OEMs or dealing with this technology changes in any way?
Chinese manufactured installation of Chinese turbines has something that's been predominantly been in China and in Southeast Asia and in Australia. But we do see an increased interest of looking at Chinese turbines because they're cheaper and they're larger to a large extent, and there's been this shift in in the opinion about between Western manufacturers and Chinese, because there's always the opinion that Western manufacturers was in a lot better quality compared to the Chinese. If that remains true, that it's still up for debate, of course. There'll be a lot of opinions on this, but I see the difference a lot less now than it was 10 years ago. That there has been that the difference between them have shifted. Then, of course, if you can buy something a lot cheaper, that becomes a lot more appealing. One thing where we still don't know how it will work out in long term is on the operation and maintenance, where it's worthwhile checking in detail. And that goes also for Western OEMs. But what is the service level that is being provided by a Chinese or a Western OEM? So I think that's what it's really going to come down to a large degree, more than necessarily the turbine cost. Because again, you need to operate these for 25 years. And when we get into these size turbines, then any kind of maintenance, any kind of component replacement, that will really that will be the most important part. I see it because again, in the old for older turbines, gearboxes, bearings is something you could get on the open market. That's not the case with modern turbines. So if you buy a Mingyang turbine, likely will not be able to buy a bearing from anyone else or a gearbox. So you're relying on the service that the OEM can provide. So I'd say regardless of which one you pick, then that's where then the service and maintenance is where you need to focus.
Yes, when we saw Argentina's wind industry develop, obviously it's not that many years ago, you were looking at servicing contracts that were designed probably copying what was first done in Europe. From your work, obviously, I presume you get to see what the servicing contract looks like, because of how it's been drafted. It will depend on who takes who has to respond to the blade repairs or blade replacements, right? When you're dealing with an O&M contract, an insurance contract. Are you seeing, I mean, the servicing approach or contractual servicing approach adapting to what was already designed, right? If Chinese OEMs coming into the European market, adapting to the customs servicing contracts, or are you seeing a new type of contract being put forward?
I've not seen much in terms of blade maintenance from the Chinese manufacturers, and to be completely frank, then for most service contract, blades are treated as they're still being treated to a large extent as a maintenance-free component, which is definitely not true. Which is also why, as an owner operator, you really need to look at this and challenge it, so that blade maintenance is included in your scope, because it's going to be very costly. Also because of there's just a general lack of maintenance crews in globally that can maintain these. So that often means that you're getting that you need to wait for a long time. So I would say in general, for contracts, I do see a lack of focus on blade maintenance, and that there's a lot of exclusions on blade maintenance. So any lightning activity is often treated as force majeure, which is counterintuitive when we're talking about carbon blades, because then lightning will be more in focus and the probability of damage is higher. So therefore, it's a bigger risk for an owner if you're taking over blades that are carbon reinforced, and then any damage to it is either your or your insurance company's responsibility. That will be a major risk.
Right, Morten. One of the things that we saw here in Argentina with the first cases of blades, right, being disassembled, and one of the questions we had from the London market was, is there a secondary market, right, for this kind of blades? Which, at least in Argentina's case, there wasn't, right? So this takes us to how to deal with blades that are no longer usable. Is any market that you see having an approach to how to deal with blades that have, obviously, because of the nature they were designed for, they have been built to last, and I understand that same nature makes them complex to either recycle or reuse or reconvert. What have you seen in this respect of both? Probably I ask Europe, who has been probably the pioneers of this technology.
Well, there's been quite a few approaches, some of them more unfortunate than others. There was a tendency to bury them in landfill for a while. luckily that has changed that approach to a great degree. I don't know of that many places that do that anymore, which is good, because it is a lot of chemicals, and it is a lot of materials that will then completely go to waste. So that is approach that's been used in the past, but hopefully it's not something we're going to see. But you're right, it is a problem that we need to tackle, because the problem is going to get a lot worse by several margins, because of the fleet is getting older. So there will be a lot of focus on how to replace these. Some of the methods that we've seen in Europe is either shredding them and using them in gravel, in cement mixing, for either infrastructure or buildings, because fiber reinforcement concrete does have a very positive effect, and that can reduce some of the steel requirements or other additives that we could use. So it's a good resource for that can then readily be used for something that supports critical infrastructure. So that's one thing. Another method is incineration, and then use it for heating. It's not ideal, but again, better than to just bury it. I prefer that we try and do as little of that as possible, because there will always be other things that we can burn. But that is a way to discard the blades, is to turn them into heat by incineration. There are some upstream technologies that are looking that does have some promise, and that is going into building recyclable blades. Several OEMs have released blades that are used on either thermoplastics or thermoset plastics that can be dissolved by chemistry. Thermoplastics is positive, because if you can extract it from the fibers, then you have you can reuse it one-to-one, like most other plastics, like polypropylene, polyethylene. Then they can go into and then become plastic cans or whatever, or new blades. So that would be incredibly possible if we can do that, but it will likely not be possible to build blades at the length that we're seeing for offshore right now. So that would again be for smaller scale, because it does not have the same mechanical properties as epoxy. So there will be some trade-offs in what is then achievable, but it could be a good move forward. Thermoset plastics that can then be dissolved is a nice idea to get the fibers released and then reuse the fibers, but it does create a solution where you need to add a lot of new chemistry in order to release the fibers. So again, I'm supportive of the idea, but I would hope that there are other solutions we can utilize. I think that what we need to do with the current fleet that we have installed is to find ways to use it, like for gravel. Could also be that we can use it to build walls for temporary housing or for permanent housing. Find creative ways to use these materials, because they're incredibly strong, long-lasting, especially if they don't see any significant loads. Then there is a lot of ways to do that. You can build surfboards from them. I know people are doing that, but I don't know I'm not sure there's enough surface in the world to take over the majority of blades that are currently is. But creative. I like ideas like this. I think we need more of to find solutions to current problems that we have, where the blades can then be part of the solution.
Right. Yeah. Obviously, you need to when building your infrastructure, or when a country has determined that wind will be part of their transition, right? They need to prepare, right? How are you going to deal with these blades? Obviously, 15, 20 years from now. And now, presumably, it also influences how each owner deals with a blade, in the sense that you always looking at a blade that has been damaged, you need to decide whether to replace the blade, or if repair is still possible.
Yes.
You think that this is an area where there isn't much chance to influence the output, or how does this? How do you see your involvement having an effect on this area?
I would say repair versus replace is something where we can really change the industry as it is right now. We do see a lot of cases where blades are being deemed requiring for replacement, where there is shell damage. It can be quite significant, but where it's then deemed easier or faster to then replace the blade. But then getting a new blade manufactured and then shipped to wherever the wind farm is something that can have a lot of lead time, and then cause a lot of business interruption. So I think one area where we as an industry can get better is actually to look at what is actually repairable, and then avoid these replacements. And if you need to replace it, then at least when the blade is down on the ground, then before sending it off to gravel or incineration or something third, then look, okay, can we refurbish this and then use it as a spare blade? There are a few challenges in utilizing secondary blades, and that is that any blade for any given blade type will not fit with blade from other blade types. That's a starting point. Then any given blade will more likely not only fit within that version. So if you have a version 1, 2, 3, 4, and 5, then all the 1s will likely be compatible, all the 2s, all the 3s. It's not a guarantee, but they will be compatible. But if you have a lot of variations within your wind farm or within the industry, then it becomes a jigsaw puzzle to then make them work. But I do think it's worth it, because sooner or later, someone with a 5 megawatt wind farm, they will have a requirement for a blade replacement. That's just very likely. And then if you take the down blades from another 5 megawatt wind farm and then just discard them, even if it could be repaired, then you're losing that opportunity. And then you're just feeding the need for producing more blades and not doing whatever you can to create a market for secondary usage, for second use of these blades. So I think it's something where we really need to push the boundaries and really think about what can actually be repaired. And I do know from industry that whenever there is not an insurance case and there's not an OEM deciding whether it should be repaired or replaced, a lot of really big repairs do get made because there was no other alternative. Alternative was to take the turbine down, and then repairs of 5, 6, 7 meters on the shell was possible, and the blade got up and running and successful. And you can do that as long if the damage is only affecting the shell, you can more or less always repair it. It's very rare that it cannot be repaired for any reason. When it's beam laminate, you do have limitations, especially with carbon. But again, if we can improve the technology, maybe we can also push the boundary here, and it will affect the number of replacement blades we need in the industry. So I think it's something where we really need to put some focus into, and maybe also push the OEMs to what is actually possible to do here.
Yeah, I remember when visiting Wind Power Lab in Copenhagen last year, one of the points your team mentioned was trying to identify any damage at a very early stage, and that is not always easy to do, right? How have you managed a way to assist project owners in identifying this damage early on? Is this even possible?
So there are technologies out there that do show a lot of positivity, that look very, very positive, and that both for acoustics but also for vibration sensors. And again, CMS condition monitoring is still a novelty within blades. It's very common for all the drivetrain products, but for blades, it's not commonplace to do, and it's always looked as very costly and unnecessary. But I would say it's actually contrary to that, because if we can get sensors in to monitor the blades and see how they behave, it also means that we'll be able to see if there is a shift in their behavior during operation, and that can tell us if a blade is changing. Then it's more likely than not that there is some degree of structural damage in it. And the earlier we can detect that, the more likely it will be that it can actually be repaired and avoid blade collapses, cutting towers, or requiring complete blade replacement or damaging other blades. So there are technologies that have a proven record of finding it. Are they perfect? No. but they're a lot better than the alternative, than going out once a year, seeing if there's something happened since last time, and then anything that happens in between was something that we haven't had no idea about if we had no way of knowing about it. It will really affect this. So I would say CMS should be something that we should consider more as a requirement in the industry rather than a novelty, because it will help it will help every party in it.
So pushing the OEMs to improve the technology they incorporate into the blades.
Well,
right? Blades or OEM or entire turbines.
You can either push the OEMs to say you need to come up with the CMS solution to detect this, and you can only do that if you demand it as an owner during contract negotiation and as part of employers' requirements. That's where you have leverage. That's where you have power. You can't do it afterwards when the turbine's being constructed, saying you would also like CMS. Then the OEM will look at the contract and read that as the Bible. But then as an owner, you will still have options. You can still take ownership of your turbines and say, okay, even if the OEM doesn't want this, I can find a third-party solution out there, and then install that on my own to get some data to help me monitor and maintain my asset, which will help you on keeping the turbines up and running, ensure safe supply of electricity. That will be a benefit for the community, and will also be a benefit for the owner in the long run, because you don't end up with these abrupt standstills. It will also help on the insurance side, because the more we can avoid, we can make the unpredictable predictable, then that also helps with reducing the risk of insuring an asset. So I would say there is all, from the owner and insurer, they should look at this like as a partnership, and then find solutions that will reduce the risk of the asset. That will be a benefit of both.
Okay. So Morten, obviously you and your team normally get involved when things have gone wrong, right? Blades falling or breaking. You must have seen some amazing stuff. Any story that stands out from these last years visiting sites?
Well, there's always a lot of interesting things happening, and blades getting damaged in various ways. I would say one of the things that really took me by surprise, and there was a few of them, but that was we had a blade on the English West Coast, and we start to see a major delamination on the blade. So we decided to go and have a look at it, and then when we sent a team up to start to scrape off the laminate, then a T-shirt appeared underneath it. Someone had, I'm just going to say, lost a T-shirt inside the blade. So it was laying there, and then it created a separation in the layers, and then that formed a delamination. The T-shirt was then removed. Was not usable, unfortunately, so we had to discard it. But the blade was repaired and restored again. But I did not expect that when looking at the damage initially. I was expecting a lightning damage or something like that, but it turned out to be.
You should have kept that shirt to remind anyone. Totally unexpected events can occur.
But we see that, and sometimes things from operation also shows up. So we had a blade tip that suddenly had a spear sticking out of it, or a metal rod, and had just punctured right through the blade. And that was during installation. Someone had used this long metal rod to guide the blade, and then when that was taken down because the blade was in place, they left it inside the blade, forgotten about it. Then when the turbine started to rotate, the spear was just ejected out to the tip of the blade, all the way out, so we could go and remove it safely. So, but I would say that was some of the unexpected things that I have seen.
Okay, Morten, thank you very much for teaching us about blades and sharing with the Valiant community all your knowledge. It's been great to have you here.
It's been fantastic to have me, Santiago, and thank you for considering me for this. Thank you.